All right, so to talk about position, distance, and displacement, that means we're talking about motion. We're talking about this concept of motion. Motion is just a change in position. Position meaning location. And generally we're talking about location relative to some other point. We call this point a reference point. Often it's where we begin, but it doesn't have to be. Okay? So if you are just getting up out of your seat and walking to the front of the room, you have motion. If you are simply sitting in your seat and waving to the person across the room, or sitting in your seat and getting something out of your book bag, you do not have motion because you are still in the same location. Your position within the room is not changed. It only is motion if you change your position, your location. When we're talking about a change in position, we can talk about it two ways. We can talk about distance, and we can talk about displacement. Okay, these are two different things. Distance does not include direction. It doesn't matter which direction you go, forward, backward, up, down, makes no difference to distance. Distance is simply the length between 2 points. Okay? So here, this little ant started here. Here's our reference point. And here, the ant went a distance of 6 centimeters. And this little ant over here went a distance of 3 centimeters. Because it does not matter which direction the ant went. Okay? Displacement, the direction does matter. Some directions are positive and some directions are negative. If you were going forward, up, north, or east, these are all positive directions. If you were going backward, down, south, or west, these are all negative displacements. You could think about a coordinate plane. If you're on a coordinate plane and you're going this way, that could be forward, that could be to the right, that could be east if you're talking about cardinal directions. These would all be positive numbers, positive directions on that coordinate plane. The same with this. This could be up or north, and that would be a positive direction. If, however, on the coordinate plane you went this way, which might be backward or west or to the left, those would all be negative directions, as would this, going down or south. These would all be negative directions. These would all be positive directions. Okay, so when we go back up here to our ant, when we look at this ant's displacement is not just 6, it's positive 6 centimeters. And this ant's displacement is not just 3, but negative 3 centimeters. Okay? There's another important distinction between distance and length. Displacement and distance. To get displacement, you take your final position, x sub f, minus your initial position, x sub I. You subtract them. So it doesn't matter what you did in the middle. It's final minus initial position. You could have walked back and forth 10 times. That is not included in displacement. However, it is included in distance. to get a total distance, you would want to add up each leg of the trip. Okay? So let's look at some examples. Here's one. If I start here, here's my reference point. I'm starting here at 0. My distance, I went 2 meters, and then I went back 8 meters. My total distance would be 2 meters plus 0.8 meters. Remember that distance doesn't matter what direction you go. So my total distance would be 2.8 meters. That's how far I walked. However, my displacement is not the same as my distance. My displacement would be my final position, which is here, minus my initial position, which is here. My x sub f is at 1.2 meters. My x sub I, my initial position, was at 0 meters. So when I say x sub f minus x sub I gives me displacement, I'm saying 1.2, a positive 1.2 meters minus 0 meters gives me a positive 1.2 meters as my displacement. Okay, let's look at some more examples. Here we've got the Earth going around the Sun. If we want to know the distance, the Earth went from A to D, we would say we would add up this distance from A to B, that distance. We would add up this distance from B to C, and then we would add up this distance from C to D. And that would give us our total distance. If we want to know our displacement, however, it doesn't really matter how far around the Sun the Earth went. Displacement is just our position at D minus our position when we began at A. So this is our displacement. This little distance right here would be our displacement. Okay, this whole thing would be my distance, but this one little part would be my displacement. Let's look here. If I'm traveling on this curvy street around these mountains, my distance would be this whole distance I rode, right, all the way to the factory, which is 200 meters. However, my displacement is not nearly so far. My displacement is the straight line from where I stopped to where I started, right? And that, it says, is only 120 meters. Okay, let's look at these examples on a number line. If I'm starting at positive 1, a positive 1 position, and I'm ending at a positive 4 position, to get my displacement, I would say x sub f minus x sub I. And that would give me a positive 3 displacement. We don't have units marked here, but we should have units in our answer. If you don't know the units, you can just simply write the word units. Okay. Here in this case, my x sub f is negative 1 minus my x sub I was negative 3. So that's the same as saying negative 1 plus 3, which is the same as saying 2 units. And you can see that I'm moving in this direction, which is a forward direction. So it should be a positive direction. So that makes sense. Okay? Here, I went in a complete circle, right? So if my x sub I was here, then my x sub f is here too, because I went around a complete circle. So my x sub f is -4 units. My x sub I is -4 units. So my displacement then would be -4 minus a -4, which is the same as -4 units plus 4 units, which gives me a displacement of 0 units. That makes sense because you can see that I started out where and ended up in the same spot. I just went in a loop. Let's look at this one. Now I'm not going left and right. I'm going up or down. So I'm starting at 1 unit and I'm ending at 2 units. So when I plug into my formula, x sub f minus x sub I, to get displacement, I can say +2 units, sorry, these should have positives, minus +1 unit gives me a +1 unit of displacement. If you look, that makes sense because I went up, so I should have a positive direction on my displacement. Here I'm starting at 2, a +2 units. I'm ending at a -2 units. So I'm going down. So I know that my displacement should be negative. My displacement is -2 units minus +2 units. -2 minus 2 gives me -4 units. So that's good because that's exactly what I predicted I should have. I predicted I should have a negative displacement. Okay? And if you count 1, 2, 3, 4 units, that makes sense. Okay? So that's how you figure out displacement. It doesn't matter what you do in the middle. It only matters how far you went. Okay? You could make this route back and forth 10 times. But your displacement is simply where you ended up minus where you started. That's the only thing that gets counted in displacement.